Greetings from the Infinite Motion Control Engineering Department. We thank you for purchasing the IMC Liquid Leak Tester and for watching this video. The purpose of the IMC Liquid Leak Tester is to replace traditional standing liquid leak test, which is commonly used in industry, in which cups are filled with liquid and allowed to stand for a set time period and then inspected for leaks. The IMC Liquid Leak Tester, when properly applied, can be used to greatly speed up the inspection process and also uncover leaks in ways where more conventional testing methods fall short. In this video, we will discuss the operator controls, test basics, how to find the optimal test procedure for testing, and maintenance. Each tester comes with an operator manual. In addition to looking at this video, we encourage our customers to consult the operator manual for further explanations. In this section of the video, what we'd like to discuss are some of the operator controls on the liquid leak tester. We'll start from the left side and work our way around the perimeter of the machine. What we'd like to first point out is the air supply regulator on the left side of the machine. It's connected to shop air and the pressure setting is set for 60 psi. This setting is always at 60 psi at all times and never needs to be changed. There's also an on-off switch here for the air supply. Down here on the lower portion of the machine we see a waste collection reservoir. The purpose of the reservoir is to collect liquid that accumulates in the pocket if a cup breaks or spills liquid into the pocket. Here we have a trap that's capable of collecting that water, that test water, so that it doesn't damage the internals of the machine. If the operator sees that this reservoir starts to accumulate liquid, he can unscrew it and then simply empty the reservoir. It's important that the operator keep this reservoir screwed tightly at all times so that it doesn't affect the pressure of the machine. In this portion of the video, we're going to talk about some of the operator controls on the front of the machine. First, what we have here is our start push button on the control panel. The start push button is used to initiate a test. Once that button is pushed, it will flash for 4 seconds, which is the duration of the test. We also see on the panel that we have a selector switch for either the left or right pocket. This is a 2-pocket tester. In this case, we only have 1 pocket mounted, so we're going to be testing on the left side. So the operator has the option of choosing whether he wants to test the left or the right side pocket. Over here we have our manual push button. The manual push button can be used to apply vacuum to the cup in the pocket for the duration that that button is pressed. This feature can be used to stress a cup to determine the weakest seal location on the cup. Releasing the push button will cause a small amount of air to be applied within the pocket to help release the cup from the pocket. At the top here we have our dial indicator, which shows us our air supply pressure for the test. This is adjusted with the regulator knob on the side of the control panel, and we can see as we turn it clockwise it increases the pressure. This pressure is the amount of pressure that goes to the vacuum venturi. And the more supply pressure we apply to the vacuum venturi, the higher the vacuum that will be generated during the test. The vacuum generated during the test is indicated on this indicator right here, our vacuum level indicator. It reads in millimeters of mercury in real time. Continuing on with the discussion of the operator controls on the front of the machine, what we see right here is our left side pocket mounted. Again, the tester uses quick change tooling, so a pocket can quickly be released or set back into position within a matter of seconds. What I want to show here is we have our piping arrangement to the pocket. You'll notice that along each port on the pocket we have labels which correspond to the actual outputs on the machine, so that connecting the right tube to the right port is simple, simply by matching the labels on the pocket and on the machine. And again, with the quick change tooling, we can put the pocket back on the machine in very quick time And for customers that have additional pockets, this is a very nice feature to have because it enables them to do tooling changes very quickly. Continuing on with our discussion of the machine controls, we'll move to the right side of the machine. We see here we have our power off on switch. The machine is capable of running at 110 or 220 volt AC, depending on whether this is an international or domestic installation. Up here, what we have are two flow controls. These are normally set at the factory, but what they do is they allow the customer to set the amount of air blast pressure at the end of the test, which is used to release a cup from the pocket. The customer will want to have these set so that they're high enough to release the cup from the pocket, yet not too high so that the cup comes flying out of the pocket at the end of the test and spills liquid. Again, these controls are normally set at the factory, but they can be released and adjusted by the customer in the field as well. Moving on, next we'd like to talk about a general test procedure. But before we start discussing the test procedure, we want to say a word or two about preparing the liquid for the samples. At IMC, what we recommend is not using a surfactant. There's no reason to use anything that will enhance the liquid flowing through the cup seals. The test itself will be aggressive enough in order to reveal leakage results. What we recommend is using simple food coloring that can be purchased at any local grocery store and coloring the liquid to the point where it's dark enough that it can reveal leakage on the cup samples depending on the cup samples pattern. In this next portion of the video, what we'd like to discuss is how to determine the optimal test pressure for a test. The maximum air supply pressure that can be used for a test is 60 psi. Practically speaking, it's possible to apply enough pressure to any cup, no matter how well it's made, and make it leak. Unfortunately, this has no utility, and it's not the way the tester is intended to be used. For best results, the air pressure setting on the tester should be set to a level that will not allow good cups to fail or show signs of leakage. The correct optimal setting can be determined through trial and error by the customer by taking known good cups and testing them by applying successively higher levels of air supply pressure, for example 35, 45, 50 psi on up to a maximum of 60 if necessary, until signs of leakage just start to be observed. Once an air supply pressure is reached in which good cups show signs of leakage, the pressure setting on the regulator can be set back slightly by a few pounds. This is an iterative process, but once the optimal test pressure for uncovering leaks is determined for a particular cup size, that pressure can be set for good as a benchmark criteria. Now that we've discussed the general procedure for determining the optimal test pressure for a cup, let's actually run through that procedure and see if we can determine it for our sample stack of cups that we have right here. So what we'll do is we'll take a cup, pour some liquid into it, set it in the tester, we'll dial up our pressure to 10 psi. And at that level, we'll probably get a fairly low vacuum level for a peak, and we'll hit the start push button and allow the test to go for 4 seconds. You saw there we had a fairly low vacuum level, which was only 28 millimeters of mercury. And then we can look at the underside of the cup. We don't see any signs of leakage at that pressure. So we'll pour that out. Toss that cup out, take another one, set it in the pocket, and now we'll turn up to 20 psi. Here we get up to about 97, 98 for a vacuum level. We take that cup out and we look for any signs of leakage, and we don't have any on this cup. So we need to go a little bit higher. So we'll take another cup, set it in the pocket, and we'll turn it up to 30. at 30 psi. Hit the start push button. We reach over 200 millimeters of mercury on vacuum. Remove the cup. Look for signs of leakage, and we have none yet, which tells us that we need to go a little bit higher. So we take another cup, set it in the pocket, turn the pressure up to 40, hit the start push button. Here we can see we get a higher vacuum level now, almost 400. Pour this out, and take another look, and we have no signs of leakage. So we need to go a little bit higher. So we're going to take another cup, pour liquid in it, set it in the pocket, turn up to 50 psi, hit the start button. Here we go even higher on our vacuum. Pour that out. And here we can start to see a little bit of leakage at the bottom of the cup. So we know now that we've reached a threshold where we're going to create a leaker. Now these were known good cups, so they're good benchmarks. So at this point, as far as our setting goes, we can take our setting now and turn it back about 5 psi. And this now will be our benchmark test setting for this cup size. Now I should mention that different cup sizes will have different pressures to apply to them because different cup geometries are different, and also the seals are different. So if a customer has several different types of cups that they're testing with the tester, they're going to have to go through this procedure for each cup in order to determine what that optimal pressure setting is. Also, the key to this whole process is, and we're going to talk in a later part of the video about just running through the test procedure now that you have the test setting, the benchmark test setting set up, is you're going to want to evaluate the cups at this setting, and then you're going to want to be taking corrective action in terms of flow and temperature and heat settings and tooling on your cup machine in order to improve your process so that you have no leakers at this setting. Once you get there, you can actually start to maybe dial up the pressure a little bit, make your test a little bit more stringent as you go along and as you increase your cup quality. And you can keep improving your cup quality that way, being confident that you are not getting leakers out in the field. And of course, the benchmark for that is, if you start to get a little bit of customer complaints one way or another, then you can go ahead and increase the pressure a little bit further so that you make your test a little bit more stringent, and you can catch those leakers as you get that customer feedback. So that's really just the gist for the procedure for setting up that initial pressure setting as a benchmark for a particular cup size. So now that we've determined what our optimal pressure setting is for doing testing with this cup, now we can actually start testing the cup production. So I have a stack of cups here. So to do my testing, I just pour in some liquid, place the cup in the pocket, press it down against the seal, push the start push button. Now I can remove the cup. And then we do an inspection of the bottom of the cup to see if we have any leakers. And I think we look pretty good on this cup. So sometimes, you'll see leakage, sometimes through the seal. Other times you'll see staining around here. That was shown in an earlier part of the video. And if you do, then you can do some more sampling. Again, I just showed one cup out of this stack, but you'll probably do several in order to give yourself a certain confidence level as you do your periodic sampling. And then if you do start seeing weakness in your seals, you can do corrective actions, again, mentioned earlier, such as maybe tooling modifications, changes in your airflow or your heater temperature settings, so forth. I'll mention one other thing that you can do here, and that is We mentioned the manual push button earlier, and that can be useful if you're not getting any leakage, but you want to try to force a little leakage, just to try to maybe see if there's some weakness somewhere in your cup. You can use that manual push button and apply a little bit more of a severe test for, say, a period of time longer than 4 seconds and see if you have any staining. It looks like I have just a little bit starting to come out here because I went a little bit longer than 4 seconds. But sometimes that's how you can use the manual push button, and sometimes that can be used as an additional tool for uncovering weak spots in your cup. In this portion of the video, what we want to discuss are several of the calibrations that you can do for maintenance. The liquid leak tester is really pretty much maintenance free, but there are certain things that you can do if you sense that the indicators or the vacuum sensor are not calibrated precisely. Now let's start with the vacuum sensor itself on the front of the control panel. Ideally, when you start a test, you should be at 0. You can see we just got a little bit of flickering between 1 and 0 millimeters of mercury, and there it changed again. It's a very sensitive sensor, and it's really not that important if you have a 1 or 2 millimeter drift in the reading to start the test. If it gets to be like 10 or 15, you might want to re-zero the actual vacuum sensor. So there's just a quick procedure for doing that. What you want to do is first come over to the side of the machine, and I would recommend turning off pressure or even disconnecting the air supply altogether. Then what you do is you come over to the sensor and you press the up and down arrows together at the same time. You'll see the sensor flash and it should return to 0. And sometimes it's rather sensitive, but so there we go. And you're just kind of re-zeroing the sensor. Again, a little bit of fluctuation of a couple millimeters of mercury really doesn't matter because the vacuum sensor is mostly for reference anyway, just so you can get an idea in real time for how much vacuum you're building up in the cup pocket as you do your test. But that's just one little maintenance thing that you can do if at the start of a test you notice that that start value, which should ideally be 0, drifts off to, say, a few millimeters of mercury. Just a very simple thing to do. So the next thing that you may want to look at on the tester in terms of maintenance for calibration would be the actual pressure dial up here, the pressure gauge. So if you wanted to reset that, the thing that you do is you come over to the side of the tester and remove pressure from the machine. Now this calibration is really only necessary if there's no pressure on the machine and the dial isn't reading exactly at 0. That could indicate that there's a little bit of internal pressure buildup inside the case of the gauge. So in order to release that, if you had to, there is a small lever on top that has an open and a closed position. So what you would do is you flip that little yellow lever over to the open position and let the gauge vent for about 30 seconds. By that time, hopefully you should be reading back so that your pointer is back and deadpanned on the 0 reading, no pressure applied. When you're done, then simply flip that little lever back into the closed position and you're good. And again, I mean, this is something that you can do once a month if you needed to. Again, the key is that if you ever have 0 pressure to the machine and you see that that gauge needle is not reading down at 0, then you know that you probably have some pressure that you should relieve in that gauge. So the next calibration or system check that you could do for the machine in terms of maintenance is a check to make sure that your internal piping is free of all leaks. Again, you can do something like this maybe once a month just to check that your liquid leak tester is operating the way that it should. So the way you do that, for simplicity, what I'll do is I'm going to remove the pocket from the machine. No need to have it on here. Simply disconnect it. And we will turn our pressure all the way up to 60 psi, or as high as that we can go. Next, we'll test the internal piping for the left side pocket position first. So we have our dial switch set to left. Right down here we've got our port for the left side vacuum coming out here. And then what we can do is we can do one of two things. Ideally we can put a pipe plug on the end. I've got a M6 female to female with a pipe plug, and this is meant to be used to close off the end of that tubing right here, which would normally go into the pocket. Or if you don't have a pipe plug, you could even use your thumb if you'd like. Just press it tightly against the end of the tube, and then hit the start push button. When you hit the start push button, if this is a successful test, we should see the real-time reading on the vacuum display sensor go at least to a minus 630 in magnitude. So I hit that, and over 4 seconds, you could see we got up to about 650, 660. So that's a good test. What that indicates is that with the left side pocket internal piping all sealed off, we can do a test and we build up to a pressure or a vacuum that indicates that we have no leaks in that portion of the internal piping. Likewise, we can test the internal piping for leaks on the right side pocket for the tester. So what we'll do in that situation, put our tube over here to the port for the vacuum for the bottom of the right side pocket, seal off the tube. Again, we can use our thumb too if we'd like. We switch now the circuit over to the right pocket. We hit the start push button, and we should see at least in magnitude of 630 millimeters of mercury to be assured that the right side pocket tubing, internal circuitry, pneumatic circuitry is working correctly. So we hit the start push button. You see we get almost to 660, the same that we had on our left side. And now we know and have confidence that the tester has no internal leaks. So that concludes our video and discussion on the IMC liquid leak tester, going over some of the procedures and the maintenance involved. Again, we just want to thank our customers for watching this video, and we invite you to just send us your questions or inquiries that you have about the operation of the equipment. Again, thank you very much from Infinite Motion Control.